A significant share of the world's most critical systems still runs on legacy code written decades ago, even as far more capable modern programming languages have emerged. The high cost of maintaining these decades-old legacy systems like COBOL and PL programs is a major burden across industries. These systems act as a bottleneck to modernizing workflows, processing data in real time, and adopting AI at scale because they are rigid, hard to integrate, and dependent on scarce expertise. To overcome this problem, government agencies and large enterprises are trying to rewrite or modernize their COBOL systems in contemporary languages. But it's not that easy. COBOL is a largely forgotten language, no longer taught in universities, and highly verbose, with too much noise around simple operations. It is built like spaghetti code, with intertwined logic and little to no documentation of the underlying business processes. So even with the necessary expertise, the task is still challenging. Now, one can use compilers and traditional tools to convert a COBOL program. However, these tools rely too heavily on surface-level input and output tables and domain ontologies to deduce code logic. They fail to capture hard-coded constants, data lineage, if-else conditions, string operations, and aggregated transformations, resulting in inaccurate rewrites. Scry AI's Datatio understands the complexity and black box nature of legacy systems at their core. Datatio data flow mapping uses proprietary AI-driven algorithms and SME-trained LLM models to reverse engineer COBOL and other legacy programs, thereby reducing time by 85% and costs by 75%. Datatio analyzes legacy programs and helps experts understand how data moves, how values are transformed, which inputs influence which outputs, where constants and conditions are applied, and what the program is actually doing from a business perspective. It does not solely rely on code comments, naming conventions, or ontologies. It works by analyzing patterns within the input and output datasets, using actual numerical and non-numerical values to detect relationships across tables and transformations. This allows it to extract key logic involving formulas, hard-coded constants, aggregation across rows or columns, string and numeric transformations, and conditional rules such as if, then else. From there, Datatio constructs a flowchart of the program's internal logic, enabling experts to infer the steps executed by legacy COBOL and PL programs and reconstruct the underlying formulas, rules, and transformations that drive the system. This reconstructed logic can then be used to rewrite, document, or support the modernization of application logic into modern systems with high accuracy. Users can also evaluate these transformations using accuracy scores and confidence levels, select the most relevant relationships, and iteratively refine results by testing subsets input and output data. Reverse engineer, analyze, and transform legacy code with precision, and future-proof your decades-old systems. Visit scryai.com to learn more.